Hello, welcome. Today let's try to solve Leetcode problem 236, lowest common ancestors of a binary tree. So we are given a binary tree. We just need to return the lowest common ancestors. So for example, we have a node p equal to 5 and co equal to 1. This is 5 and this is 1. Yeah, so one node at the left side, another node at the right side. So we need to return the lowest common ancestor. So it is 5. Yeah, because for this left side, for this 5, there are common ancestors like 5 and 3. And from the left side, for the node 1, the ancestors will be 1 and 3. So the lowest common ancestors will be 3. Yeah. So let's take another example. So if p equal to 5 and co equal to 4, so this is 5 and this is 4. So the lowest common ancestors will be 5. Yeah, because for 5, the lowest common ancestors for itself, it will be 5 and 3. But for this 4, the ancestors will be 4, 2, 5, and 3. So the common ancestors, the lowest common ancestors will be 5. And similarly for the right side. Yes, let me first go to the whiteboard to explain the recursive solution and then go to the code editor to finish the coding. Yeah, so we're going to use this example. So if we were to check 5 and 1, so 5 is at the left side and 1 is at the right side, and this is the root. So this is just one case. Yeah, so if one node, yeah, if one node at the left side, another node at the right side, yes. So this is the first case. So it is one node at the left side and another node at the right side. So we're gonna return the root. So this is 3. This node 3 will be the return. So what if we were to calculate like 5 and 4? So this means the p and q both at the left side. Yeah, they are not at the right side. So what we're gonna do? We're gonna use the recursive function to find this 5. But how should we find 5? Yeah, we're gonna check if there is a p or q at the left side or at the right side. So from the right side, we didn't find this 5 and 4. So it is we're gonna return a none. Yeah, but at the left side, we can find this 5. So this 5 is not p. So we're gonna return. So the second case is if it is the left side, we find the node. Yeah, we're gonna return this node. So return the root. So this is for the left recursive solution. So this is from the left side, we're gonna use the recursive solution to find. So left side is the subproblem. Or there's another case. Similarly, we can let the recursive function go to the right to check if it is from the right side. So for example, we are checking maybe 1 and 8. So 1 and 8 at the left side, we didn't find. So what are we going to return? We return a none. Yeah. So from the left, it is a none. But for the right, we are sure it has the values. So we're going to use the recursive function to let it go to the right. And then we're going to check if we find this 1 first. So we're going to return this 1. We don't need to find 8 anymore. Yeah, because we are sure if we find this 1 first, there must be other values like 8 or 0. So we're going to return this 1 immediately because we are sure we find the value. Yeah, we just need to find one value and then return. We don't need to find both values. Yeah, so for the first case, if we are sure at the left side there's a value, maybe 5, 2, or 4. At the right side, maybe there is another value, 0, 8, or 1. So we're going to return this 3 immediately. So this is the first case. So for the second case, if it is at the left side, so we're going to use the recursive function at the left side to find. If we find that node, so we're going to return that node immediately. Or it will be the recursive function, or maybe it is 7 and 4. Yeah, maybe, there are also 3 cases. If it is the left and right side, we're going to return 5. If both at the right side, we're going to return this 5, or both at the right, both at the left side or right side, we're going to return this 5. So there are also like 3 cases. Yeah. So yeah, this is the problem. So from the beginning, we're going to attack the left side and the right side. Yeah. And then we're going to use the recursive function for the left or right. For each left or right, there are also 3 cases. But what about the return? The condition to attack the return is if this node, yeah, if we are attacking this node from the left side, we didn't find it. Yeah. Or we can find from the root dot value. If root dot value equals p or root dot value equals to q, it means we find a node. So we're gonna return this root. Otherwise, we're gonna use the recursive function to attack. Yeah. Let me go to the code editor to code it. Yeah, this is a little bit difficult to explain. That is why I really explain about the tree problem, because the tree problem is just not so difficult, just to practice. After practice, you understand the recursive function, and then try to practice more about the tree problem, and you will know why you solve it like this. So we're gonna first check if the root exists or not. Yeah, the problem said this P and Q will exist in the tree. It means we can always find the lowest common ancestor. Yeah, but this if not root, it means from the left side if we didn't find, or from the right side we didn't find. So this is we need to check. Or root equals P, or yeah, let's use this, or root in PQ in this array. This means root equals to P or root equals to Q. So we can return the root. Yeah. So this means if the root is none, so we're going to return the root, return none. So if we find it is a P or Q, so we're going to return this P or return this Q. So this is the condition. So this means, yeah, if we find the root, we're going to return it immediately. Yeah. Now, yeah, so this means if the root is inside P or inside Q, we're gonna return this root immediately. Now we are going to use the left and right. So the left should be equal to self dot lowest common ancestor with root dot left P and Q, and the right should be the same, self dot lowest common ancestor root dot right P and Q. Yeah, so this is the recursive function we get from the left or the right. Yeah, so if left and right, so this means if the root ancestor, this means if we want to find P equals to 5, Q equals to 1, so yeah, we find the value. So it means the left has a value which is 5, or right has a value which is 1, which is what we are find. Yeah, because recursive function gonna check if root inside P or Q, we're gonna return this root. If both side has a value, so we can return this root immediately. So we're gonna return the root. And if there are 2 cases, left, so we're gonna return the left. Yeah, and else we're gonna return the right. Yeah, so this means if at the left side and both sides we find the node P or Q, we're gonna return this node 3. Yeah, if we didn't find both of them, maybe at the left side, yeah, or at the right side. If the left, it means the right side is none. So this maybe we're gonna find 5 and 1, or 5 and 5 and 4, or maybe we're gonna find 5 and 4. It is at the left side. Yeah, because at the right side, the recursive function gonna return a none because we didn't find. If we find something, we're gonna return this P or Q. So PQ is not none. Yeah. So this means if it is the left side, we're gonna use the recursive function, this left. From the left side, we're gonna find. Yeah. After the recursive function, there will also be 3 cases. At left or right, or both at left or both at right. Yeah. Similarly, for the right, it's gonna be the same. For the binary tree problem, it's gonna be the left and the right would always be the symmetric. Yeah. So this is the left, right, and here is also symmetric. So let me run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and the time complexity is O(n). Because it is a tree traversal, we're gonna traversal each of the node, and the space complexity will also be O(n). Because if this structure of the tree is linear, so if it is linear, the space would also be O(n). Yeah. Thank you for watching. See you next.